Okay, so I got a couple questions on section. Let me write this a little better. .5. Number 23. The Prius problem. So it says a person drives her Toyota Prius on the road trip. At the start of the trip, she fills up the 11.9 gallon tank with gasoline. During the trip, the car uses about 0.02 gallons of gasoline per mile. Let G be the number of gallons of gasoline remaining in the tank after driving D miles. Okay, two numbers came out of that. So initial amount is equal to 11.9 gallons. Second number that came was the 0.02 gallons per mile. Now, the section we're working on is rate of change. So we're saying that for every mile, we waste this much fuel. So this here is our slope or change in rate. So if we were going to put that in an equation, that's Rm. M equals 0.02. But since we're wasting it, it's a downward facing slope, meaning negative. That's all it means. Since we're wasting it, it's going down. So our slope is negative 0.02. Our y-intercept is the initial amount, which is the 11.9 gallons. So if we were to plug this into our equation, y equals mx plus b, this one here is our slope. So this one would go here, and this y would go as our b. Now, they want it in terms of g is going to be equal to number of gallons that remain. D is going to equal miles, number of miles driven. And if we were to graph that, it makes sense that, let's say, after 0 miles driven, we would still have 11.9 gallons, which happens to be our y-intercept. Because say we did this. Say our equation is G is equal to negative 0.02 D, because we want that in miles, plus 11.9. If we were to substitute this D with 0 miles, so we would get G is equal to 0.02 times 0 plus 11.9. So the 0.02 times 0 is 0, so we don't care about that no more. So it says G is equal to 11.9. And this is our y-int, if we wanted to check for it. Now, let's see. Now that we have our equation, let's see what they are asking for in A. So A says, or asks, what is the slope of the linear model that describes this situation? What does it mean in this situation? So in this situation, this is our slope, and it's saying for every mile, so that's D, for every mile, we lose fuel at 2 times each mile passed. That's what that means. B. What does this mean? Okay, it says, what is the g-intercept of the model? What does it mean in this situation? So for g-intercept, we're going to have to set our d equal to 0 to see what, and that's basically our y-intercept. So g is equal to 11.9. What does this mean? It means after 0 miles, we should, in theory, have a full tank. That's what it should mean. It says perform the unit analysis for the equation you found in part C. So we found C is to find the formula, which here it is. G is equal to negative 0.02 D plus 11.9. Our slope is a rate of change, so it's in gallons per, let me change color. G is equal to negative 0.02 D plus 11.9. Our slope is in gallons per mile. Our y-intercept is just in gallons. Now, let me make more space here. Okay. All right, let's see. For E, let me change color again. E, if the person drives 525 miles before the refuel of the car, how much gasoline is required to fill up the tank? So it's saying, let's not take this in consideration yet, but let's plug in the 525 into D. G is equal to 0.02 times 525. We're not concerned about the negative here because we just want to know how much fuel the person needs to fill up their tank to drive the 525 miles. And this should give you 10 point, let me do the math. Okay, let me get my calculator. 525 times 0.02, 10.5.